Welcome to the deep dive. Today we're jumping into something that honestly sounds a little bit like magic on paper.
It really does.
We're talking about taking standard PC inputs, your keyboard, your mouse, a high-res video signal, and stretching them over massive distances.
And doing it with, surprisingly common cables.
Exactly. Our mission today is to really get into the nuts and bolts of a system that pushes legacy tech like VGA to its absolute limits, specifically the NTI ST-C5VRS-R-1000SP receiver.
And that gets us to the core technology here, which is KVM extension. That's keyboard, video, and mouse.
Right.
It's all about moving the user far away from the actual computer. So you have a pair of boxes, a local unit at the PC, which is probably in a loud server room.
More secure area.
Exactly. And then the remote unit, which is where you are with your monitor and keyboard.
And the headline spec here, the number that just jumps off the page, is the distance. We are talking about full control up to 1,000 feet away.
It's a staggering number. That's more than 3 football fields.
So how on earth do they pull that off?
Well, this is the really elegant part. It's all done using standard, off-the-shelf networking cable.
You're kidding, not some proprietary thing.
Nope. Just KT5, CT5E, or CT6. It's the same stuff you'd use for your internet with standard RJ45 connectors. That's what gives it that rugged multi-platform support for Windows, Linux, anything really.
Okay, so here's the question any technical person's going to ask you right away. When you say 1,000 feet, my mind immediately goes to, okay, what's the catch?
And there is one, of course.
What resolution are you sacrificing to get that far? Because copper over that range usually means a noisy, unusable video signal.
That is the critical trade-off. You don't get peak performance at peak distance. So if you absolutely need that full 1,000 feet, your resolution is capped at 1920 by 1200 using UTP-CKD5. But, and this is a big but, if you want the ultra-high industry-leading resolution of 2048 by 1536,
which is incredibly sharp even by today's standards.
it is, then your max distance drops to 600 feet.
600 feet is still an incredible distance for an analog signal at that resolution. So how is that video signal not just a mess of static and color bleed?
Now you're asking the right question. The problem isn't just getting the signal there. It's making sure all the parts of the signal arrive at the same time.
You mean the red, green, and blue channels?
Precisely. The problem is called color skew. Because those 3 color signals travel down different twisted pairs in the cable, they can arrive at slightly different times.
Which would look like what, ghosting or blurry colors?
Exactly. Misaligned colors. The system has to actively and intelligently compensate for that delay.
So this is not just a dumb amplifier. It's actually retiming the signals.
It's an intelligent timer, yes. With surgical precision, the unit automatically adjusts for the cable length.
And how fine-tuned does that correction have to be?
We're talking nanoseconds. The maximum adjustment is up to 62 nanoseconds, and it tunes that in tiny 2-nanosecond steps. That's what keeps that 2048 by 1536 image perfectly sharp.
Wow. And I saw in the source material that once it's dialed in for a certain cable length, it stores those settings automatically.
It does, which is essential for reliability. Plus, you have to think about the environment. These things are built into rugged steel boxes and have surge protection built in.
Which you definitely need if you're running a cable that long between buildings or floors.
Absolutely.
Yeah.
A nearby lightning strike becomes a very real concern. And for more industrial uses, they even have optional RS232 control, so you can send serial data down that same single cable.
So to kind of wrap up the mission here, what we've seen is a system that uses simple everyday network cable to throw a really high-resolution video signal hundreds of feet.
And it does it by being incredibly smart about signal timing and being built tough enough for the real world.
It's a fantastic solution for overcoming physical distance with some really clever engineering.
Right. And that leaves me with, I guess, a final thought for you to chew on.
Go for it.
If a system that was designed for legacy tech like PS2 and VGA can send a 2048 by 1536 video signal over 600 feet of plain copper wire just by tweaking signal timing down to the nanosecond.
Yeah.
What does that tell you about the true untapped potential of all that standard copper wiring we so often dismiss as obsolete in the age of fiber optics?